Hey guys, so in this video, I'm going to be explaining my project, which is Supply Chain Insights. Supply Chain Insights is a application which can help users provide more insight into complex supply chains and identify patterns or extract crucial information, which usually is very difficult to find from ERP systems. So in this case, I have taken a healthcare supply chain wherein it to analyze antiretroviral and HIV lab shipment pricing and volumes, and doing this through graph databases. So let me start off by saying the entire architecture of the application. I use fine-tuned models plus RAG features uh, to form the application. The entire application is built on Python and Streamlit. So now with Python, I use Colab and Lightning.ai because they have GPUs to fine-tune three models, which is Phi3, Llama 3, and OpenAI. So for Phi3 and Llama 3, I deployed the fine-tuned models to Hugging Face. This fine-tuned model will help convert natural language to Cypher queries. What are Cypher queries? Cypher queries are like SQL queries, which in SQL is with respect to relation databases, and with Cypher queries, it's with respect to Neo4j databases. Cypher queries help tap into Neo4j databases. So these fine-tuned models were trained on over 200 different questions to help convert natural language to Cypher queries. Side note, this was a project which I worked on during my co-op, with wherein the supply chain team wanted to convert their not Neo for the databases, but their Stardog databases, which are knowledge graph databases, to help convert natural language to Cypher code to a Sparkle queries, which is Sparkle queries is a different type of Cypher query, which is used to tap into Stardog databases. So these models were deployed on Hugging Face and tested it out on LLM and Olama. And I'll come to this in the last. I finally also tested OpenAI, which I have tested here. I fine-tuned it using their UI, whereas these I fine-tuned it using Jupyter notebooks. And due to their ability to integrate into LangChain easily, I use LangChain to facilitate OpenAI's my fine-tuned model as well as its API. And I use LangChain's multi-agent tool facility, which is wherein I can depending upon the type of job, I can call in different agents. I used the vector chain, a vector search, a QA chain, as well as a fine-tuned model chain, which is to call in my fine-tuned model wherever necessary, and to tap into my Neo4j database, which contains my entire supply chain data set. Now, all of this was hosted on Streamlit, and a user can tap into supply chain insights through Streamlit to access the entire application. So let's go through the entire why I've used graph databases is because we can see here that we can see here that this is a product, and each product has so many dimensionality, which is the country, vendor, brand, product group, office, and subclass, and each product consists of multiple different features. And this multi-dimensionality is why graph databases can be used to track supply chains easier compared to relational database like MySQL. Now let's go to the application real quick, and I'll launch the application. So this might take a few seconds. And in the meantime, I'll also explain that each of the an additional feature is the key feature here is for the graph database, a RAG application, a fine-tuned model, as well as performance monitoring using the RAGAS framework. The RAGAS framework helps to analyze various parameters in how your RAG performs. For example, it can also about how the model is performing with respect to various metrics. And I have given a set of features which can be used to track how good the performance is. So let's start off by asking a few questions. So as you can see, it's about a product. So we can see, give me the country we supply the most products to, and the count of the number of products. So now this will launch a separate chain in the backend, which is the question chain, and it will give me give me the answer through the cipher query chain, which is a chat query chain. So South Africa with 1,400 products. So now I can also see which brands supply these products, which is tell me which are the brands which are shipped to South Africa. So this will launch a separate cipher query chain to see which are the brands. So you can see that it is going through multiple dimensions, which is the brand, the product, the weight, the country, and then getting me the list of brands which are present there. So now I can also see now we know the brand which are there. So now, for example, if I want to see uh, the different countries, uh, so I want to see all the countries which the brand, let's say, generic is going to. You can also say give me the query to find the countries which the brand generic is available. So this will launch a separate fine-tuned chain, which is the fine-tuned chain, and it'll give me the particular set of let's just retry this. So this will launch a separate query chain and it will give us a set of fine-tuned models, fine-tuned um, model here, which is the fine-tuned model essentially is trained on over 200 questions to convert natural language to cipher queries. And this will allow the user to tap into the database, which is right here, which is here. I can also show you the particular. So it is the product, the brand name, and it will show us all the countries which it's particular. So we can see the countries here. So this is what the fine tuning does. It will convert any product, any user query to cipher query. So I can also additionally another feature is give me the plot of the number of products by each brand. So if we can ask this question, it will give us a plot usually. But if we don't mention, it would also it will also give us a different product information, which is I can also say give me a count plot of the number of products by each brand by each brand. So this will launch a separate visualize chain, which will help me visualize the data as well. This is another feature which I've also added, and it will generate a plot in the backend, and we can see that generic is the is the brand which has the most. And an additional vector search which I've implemented is also you can also say I want to see the products which have which contain 150 milligrams and 60 tablets. So if I say this, the backend it will launch a new chain which vector search and will give me all the products which are lamivudine, which is 150 grams and 60 tablets each. Now we have interacted with the app. We can also go and see we can go to the monitor performance tab. In the backend, it will analyze, it will read all the data which we have interacted with, the questions, the answers, and it will evaluate the results in the backend using the Ragas framework, which is an API, and it will give us a table which contains each of the results. So this was the question we asked. This was the answer. This is the context, the faithfulness, and the answer relevancy. The answer relevancy is how the faithfulness is how relevant it was with respect to the particular output it gave, as well as the answer relevancy is with respect to how good the answer was, whether the answer was relevant or not. We can see in most cases the answer was pretty relevant, but the faithfulness was not. This is because the context, for example, LangChain has only a maximum of 10 different outputs it will show us. So if, for example, if there are over 100 different countries, the LangChain will not give us all 100, it'll just give us 10 different countries. So hence the faithfulness is compared with respect to the context and the answer. So it might not all be there. Hence you're seeing 30%, 75%, and all of that. So now that is with respect to supply chain insights. So the to go back to our entire project here, I can show you how I have fine-tuned each model. The model which was fine-tuned were 5.3, which all of these are available on Hugging Face, and you can go and see each of them. So I use 5.3, Llama 3, and Llama 3 8 billion parameters, which are developed by Neo4j professionals. I fine-tune my own model as well as use a model fine-tuned by Neo4j. I generated the training data for them, and I these are notebooks to find out each of these fine tuning. And here is why I did not go ahead with an open source. It's because of the fact that each of these open source models takes a long time to run. For example, this was a model which I fine tuned, which was text to cipher using Llama 3. And it took almost 380 seconds or 300 seconds or 250 seconds on average for each of these to run. And I think this is because of the configuration of my local system, which is I could not tap into my GPU, and this was my configuration on my local system. And essentially, I ran this on GPT 3. And these are the notebooks which I use to fine tune. For example, let's go through one of the notebooks real quick. You can see all of this on the LinkedIn, on the GitHub repository. So I fine tuned it using Unsloth and essentially ran the entire, I hyperparameter tuned the entire configuration. I ran the configuration and I used this on GPU. As you can see, the loss is reducing, and I have the losses right here. It's reducing perfectly, and the learning rate is pretty good. And also we can see that it did pretty well, but unfortunately, and even in the inference, we can see that it did pretty well. But due to its slowness, I was not able to use it here. Additionally, you can see on LM Studio here, I have actually loaded the .gguf model, which is about 4 GB. I've also loaded it on Olama and tried it locally as well. And as we can see, we can really quickly see whether see it loaded on Olama. So here is Olama list. So we can see I have, so this is the LLM which I fine tuned here. There are two LLM which I fine tuned here, and this is the one by Neo4j. Each of these are for about 4 GB each, and it is quite large and took almost a really long time to run. And hence I did not go ahead with this. And finally, I turned to OpenAI, wherein I generated my data and I dropped it in here. It was fairly simple to construct it, and it was pretty mainstream. And I was also able to access the APIs and implement it in my application easier. There are pros and cons which I have mentioned here, which I mentioned here as well. You can go through these notebooks and my models which I have on Hugging Face. Essentially, and you can also go through the project report which is available here. This is my project end to end, and there's a lot of scope for improvement, and some of it being that implementing the graph databases to show much more different relationships, as well as implementing a much more fine-tuned model, like you can see here. We can improve the hyperparameter tuned right here, get into the nitty-gritty details and improve the hyperparameter tuned models and make it much more robust compared to OpenAI, wherein privacy is not a very key detail. As you can see here, in my entire application, I have not shared my data with the backend or with OpenAI. It has all been through Cypher queries or through vector searches. But in the case of vector search, I have created the embeddings with that, so that is not an option. A better option would be to obviously fine tune the model. As you can see, with the fine tuning, I was able to get access to the data set, which is access the entire database much more easier. And this is something which is upcoming in multiple pharmaceutical companies which want to use graph databases to understand genome sequencing as well as supply chains and other crucial products, other crucial domains, where there are multiple relationships to understand. And this is definitely a great entry point to understanding, to helping different organizations understand and to make it to get all right on their fingertips. Thank you, and yeah.